This video will be talking about measuring sustainability. In the previous lecture, I've mentioned about is there a way to measure the impact of our lifestyle. So I would like to introduce this index called ecological footprint. So ecological footprint measures the total amount of land and resources used. Ecological footprint analysis compares human demands on nature with the biosphere's ability to regenerate resources and provide services. It does this by assessing the biologically productive land and marine area required to produce the resources a population consumes. So the reason why I would like to introduce this index is because I have been researching about some ways to measure our behavior, and then I came across to know this ecological footprint. And the reason why I was kind of like digging deeply into this topic was because when you are trying to actually measure our activities, which is represented through CO2 emissions, most of it they are in fact represented through units that are not easier for us to understand in terms of space. So ecological footprint for me was quite important because this was one of the only ones that was able to translate this CO2 emission, which usually the unit is like gallons and stuff like this, and then they would translate it into space. So if I just explain you a little bit more about what is ecological footprint, is that our lifestyle can be understood in terms of different components, which are food, housing, transportation, goods, services, and waste. And then somehow these things has been translated into CO2 emissions, and then again it goes back to understanding into hectares of land. So this is a footprint component. It's a system diagram to show how the components are being translated into this the hectares of land that it can absorb. So our activities can be differentiated into these components, which I have mentioned earlier on. And then these things can be also re-represented in terms of space, which are here in this sector. So food can be understood in terms of how the agricultural land is impacting us. And then all of these things can be broken into smaller pieces. And then these small unit types, which I call it the unit type, can then be translated into these components, which are actually the surface area that can absorb this CO2. But what we need to pay attention is that this fossil energy is actually something that eventually be replaced into other lands. So this is why we need to reduce the amount of fossil energy, because fossil energy itself, it does not really absorb the CO2 emission, but it depends on the other lands to solve this problem. So this is a diagram to show the world biocapacity. Biocapacity, it means regenerative ecological area, which is also represented in hectares. So all this area, I've only shown the arable land, pasture and forest, but these are the distribution of where you can find this area that are regenerative. This diagram shows footprint per capita. Footprint per capita in this case is a world average. So in world, if we divide the whole entire world with the population, then per capita, per person, we are supposed to have, we are actually using 2.8 hectares per person per capita. And so if we compare this with this regenerative land, which is the biocapacity only has 1.9 hectares per capita. So you can see that this number is larger. So this is why I'm saying that we are exceeding the carrying capacity, and therefore we are actually not allowing enough time for the land to recover or regenerate. And I would like to also just mention one point, that this analysis was made in 2000, around 2001. So the numbers are quite old, but it's just for you to understand in terms of reference. The numbers doesn't change too radically, so I think it's easy for you to just understand using this old number. But in terms of statistic, don't use this number because it's not updated from 2001. So just moving on, in terms of understanding the concept behind the framework behind the ecological footprint, um, this diagram shows ecological footprint of nations, and at that moment, around 2001, the highest was UAE, which was 16 hectares per capita, and then number two, Singapore, was 12.3 hectares, and also same to USA, 12.3 hectares, and then you have Denmark 10.5, and then Kuwait 10.3. So from this diagram, you can understand that in the previous one, it shows that we are already exceeding the biocapacity of 1.9. We are using 2.8. But then if you look just nation by nation, there are some nations that is really using a lot of hectares of land. So this is to understand the biocapacity versus the ecological footprint. If we just divide it simply, frame it within the nation itself. So you can understand Hong Kong and Singapore, they are like outstandingly high. This is because in Hong Kong and Singapore, they don't really have this regenerative land, but they are using a lot of this footprint. And then therefore, in terms of the relationship between biocapacity, it's a lot higher than what they should do. So if we think of the nation as one thing, or if we try to understand that we are sharing the entire world equally, these numbers will change. So in terms of the unsustainable world that we are facing, mentioned earlier on, we are exceeding the carrying capacity, but in fact, because we are exceeding this, we are actually not providing enough time for the capacity to regenerate, and then therefore we are facing this overshoot. And then more and more we increase this, the more and more the regenerative land cannot be reproduced, and then therefore this will decline. So this is the kind of alarm that we should be paying attention to. And so the balance between the carrying capacity and the population, or actually it's not about the population, it's about our behavior, or it's about our activity, that we should actually be paying attention to. So what in our lifestyle that makes biocapacity unable to regenerate? So I will explain a little bit in detail about this. The example of ecological footprint friendly in terms of an ideal situation. So transportation is actually one of the biggest components in terms of footprint. There are three types of transportation system. One is self-propelled, which means it's like walking and running. There's also electricity, and then there's fuel. So self-propel, of course, is the best because the energy is taken from food, which is almost ignorable. Electricity propelled is better because the energy can be generated from renewable energy. And then, so therefore, nowadays we are really increasing a lot these electricity vehicles. The usage of fuel propelled should be as minimum as possible because the energy could only be generated by fossil fuel. So related to the electricity car that we are producing nowadays, one of the biggest issue that we have is of course airplane. So airplane of today cannot be electricity, it still needs this fossil fuel. So in fact, in order, if you are thinking really about sustainability in terms of ecologically friendly, people should not really be traveling by air. So the next one about housing. Housing depends on how many people live in how big the size is. So therefore, many people living in small house is better, of course, because the amount of house-related appliances such as construction materials and electricity consumption can be shared. In terms of the abstract model of the ideal city with 1.9 hectares per capita, we can understand that the city it should be a 60-kilometer diameter in size. The total number of populations should be around 150,000 people. And then people should be living in houses smaller than 45 square meter with minimum of 2 persons per house. It should be totally self-sustained with no airplane traveling, and maximum travel distance should be 60 kilometers per week. So moving on to this case study, so you might think this ideal city that I have just mentioned is completely out of nowhere, but in fact there is a case study that has been actually been implemented. The example that I'm going to show you is in UK. It's called BEDZ. It stands for Beddington Zero Energy Development. So BEDZ is the first largest scale mixed use sustainable community with 100 homes, office space, so it's a Soho actually, for around 100 workers and community facilities completed in 2002. So I've actually visited there. So all the photos that you see are taken by myself, and then I visited there maybe around 2004 or 5 around there. So it was still relatively new. Perhaps the situation today might have changed. So this I'm not so sure. I'm not really updated with that. But what I can show you is what I saw in 2005. In terms of the sustainable development, of course, one of the biggest component that they will have to think of is this energy efficiency. So what do they do in this area is that the house, it faces south. It takes an advantage of the solar gain. Of course, if you're facing south, you are naturally getting the solar energy, the solar, the light from the sun. And then the glasses, they are triple glazed and they have a high thermal insulation. And they are also using a low impact materials. Therefore, the building materials are selected from renewable or recycled sources within 56 kilometers of the site to minimize the energy required for transportation. So, as I mentioned, in the ideal city, it's a 60 kilometer in size. And so 60 kilometer is one of this threshold number that you should pay attention to. And then therefore, having that in consideration, because this is based on ecological footprint, all the materials that they have been used to construct the buildings, they are actually being produced and purchased within the 56 kilometer. However, what people here told me was that in fact this very high insulation window, it was not really purchasable, or they couldn't find it locally, or they couldn't even find it in the UK. So they had to actually ask to import it from Scandinavian country. So that apart from this one, all the materials they are actually to reduce the transportation. They have been actually found all of it in the local area. In terms of the naming of this area, it already suggests that it is a zero energy community. So the project is designed to use only energy from renewable sources generated on site. So there are 777 square meters of solar panels. Moreover, there are waste recycling facility. So you will find these refuse collection facilities to support the recycling. So the image here is this waste recycling facility. And in terms of transportation for the community who are living here, using cars is discouraged, and then instead they are encouraged to use public transportation or using cycling and walking, which is about the self-propelled transportation system that I mentioned before. and it has a limited parking space, and then therefore if you own a car you may not find a space to actually do the parking. So just to actually give a little bit more information about this zero energy, what does it mean is that maybe you already know, but zero energy doesn't mean that you are producing and consuming and then it becomes plus minus zero. The idea behind it is that this kind of renewable energy, especially the solar energy, it cannot be stored. So you cannot have a stock. So if you have a lot of uh, energy being produced during the daytime, it doesn't mean that it can be supplied during the nighttime. So what they do is a trading between the electricity company. So the amount of surplus energy that has been produced will be sent to the energy company. They will buy from you, and then what they do is in return they will give the energy back to you during the evening time. So this is the idea behind the zero energy. So zero energy, it doesn't mean that in one facility you are able to produce and consume and becomes plus minus zero all the way through. There is a kind of like a trading in between. And then another thing that I would like to also mention is that about the transportation is that you might wonder how people will be doing their daily shopping. So what I have understood is that every day there's a truck that comes to this community, and then basically you will buy your daily grocery there, and then so this is how they have been also discouraged to use their car, and then so instead of them going to the shopping area or to the supermarket, the supermarket will come to you, and then here it serves the big community. So that is the idea behind this transportation system, which is beyond this. It's beyond just the share, the car share. To summarize in terms of the performance, this area, bed set, the total energy used in the home is been 60% less than the average homes in the local area. So this is significantly lower use of energy for heating, 77% lower than local average, and electricity usage, which is 45% lower than the local average. The photovoltaics supplies around 20% of the electricity, and lower rate of car ownership and annual mileage reduced by 64% compared to national average. The lifestyle changes driven by a strong community, including high recycling rate, 60%, and sustainable food choices. So the case of Betset is really relevant for us to be able to understand the reality, how the ideal situation has been translated into reality, and then how the people are actually living in this kind of environment. However, my question is that is sustainability really about just the balancing between the ecological system, which is, yes, I understand that this is really important because we should not exceed the carrying capacity. Otherwise, it will cause us in an unstable condition, which will lead us to unsustainable society. However, on the other hand, we should also look into the quality of life. And then here in this society, you are only allowed to move around in a certain kind of distances. Only in terms of also the shopping, they are not able to actually go to the supermarket. The supermarket will come to you. You are actually stuck in the community. However, I think when you look at the dynamism that our society has, perhaps some kind of flow and some kind of movement is a part of our life, and then it is something that we are seeking for. And then so I think this is really relevant in terms of actually representing in reality the ideal situation translated into actual space. However, it also gives us a lesson of rethinking what is beyond just about balancing ecosystem, which is really about the life, the human life, and then what does it really mean in terms of quality of life, and then what does it really mean in terms of social sustainability, not only in terms of the environmental or ecological sustainability.